Hey guys, welcome to my YouTube channel. Today I'm going to teach you about Subtractor. So Subtractor is a digital circuit that is used to subtract one binary bit, not one. It is used to subtract binary bit, one binary bit from another binary bit. So first we have there are two types of subtractor, half subtractor and full subtractor. So half subtractor subtract one bit binary from another bit. So we just have to write a and b. So what will be the combination for these two? As we all know, the combination will be 0 0 0 1 1 0 and 1 1 for this two variable binary number. So as a this is our input, and as a output, or if after subtracting, as output it will produce difference bit. For difference bit you just need to have to write DIF is enough, and the second one is borrow bit and difference bit. So if we subtract 0 from 0, like if we see in decimal number, this 0 0 is 0, this one is 1, this is 2, and this is 3. Yeah, in decimal form this is 1 0, this is 0 1 is 1, 1 0 is 2, and 1 1 is 3. So if we subtract 0 from 0, it will give 0, and we don't have to take any borrow. So let's write 0 for this. For 0 and 1 you can't subtract because 0 is less than 1, so you need to take a 1 bit borrow from another bit. So if we take 1 from 1, so as we already know, this is 1. Yeah, in decimal form this is 1. If we take 1 and add, it will become 2. So if we subtract 2 from 1, we'll get 1. So for 1 minus 0, you can easily write difference which is 1, and the borrow you don't have to take any borrow. So for 1 and 1, the both will be, so 1 minus 1 will be 0 0. You don't have to take any borrow or anything. So for difference bit, look at that. So we have minterms, two minterms, 1 and 1 here, two minterms, and the minterms are 1 and 2, minterms 1 and 2. So this is a complement, this one is b plus, look at here, a and b complement. If you know logic gears, this means a XOR with b. For borrow bit, for borrow there is only one minterms in 1. This so just see, this is a complement. If 0 then complement, if 1 then just write whatever it is, b. Yeah, just we found the equation for these two. So let's make a diagram for this. So diagram for a, make a line for a and make a line for b, and XOR of a and b, a XOR with b. So this will produce a XOR b. So what is this? Yeah, this one is difference bit. And for borrow bit, you can connect from this, but if we do like this, again make a and a complement we have, so we have to make a NOT gate. So NOT gate, so a NOT gate produce a complement and b, just b, and their AND gate. So what will be a complement b? So this one is borrow bit. And so yeah, that's it for half subtractor. And for full subtractor, for full subtractor, there will be three bit for 3 bit. I'll make 3 bit where first bit will be a, second bit b, and the third bit b in, or simply you can write c if you don't understand b in. C is also a valid name, and as an output it will produce as like this difference and but borrow out or BOUT, whatever you want. Let's first let's make a table for this. A, B in, and difference bit and borrow out. Yeah, BOUT, borrow out. BOUT means borrow out. So what will be the first? Let's make a table. So you can remember A, B and B in as an input, and difference and borrow out as an output. Let's make a table for this, and A and B. Yeah. Okay, what will be the combination for this? 0 0 0 4 0 and 4 1, 2 0 2 1, 2 0 2 1, 0 1 0 1 0 1 0 1. Yeah, that's it. So if we see these numbers, this binary in decimal form, so 0 0 is 0, and this one is 1 2 3 4 5 6 and 7. So see, if we subtract 0 0 0, then difference bit and borrow out bit is same, 0 0. If we subtract 0 from 0, you can't subtract directly, you have to take a borrow 1. So if we take 1 and add this 1 to this 1, it will become 2. If we subtract this 2 from 1, it will give 1. For this 0 minus 1 won't, so because we have to take 1 borrow, so yeah, 1 borrow, and after taking 1 borrow, it will become 3. So 3 minus 2 is 1, and 1 minus 0 is 1. Again 0 minus 1 you can't, so you just need to take 1 borrow 1 bit, so it will become 4, and 4 minus 3 is 1, and 1 minus 1 is 0. Here difference is 1, and you don't have to take any borrow, because you can subtract 1, you can subtract 0 from 1, 0 0. So here 1 minus 0 is 1, gain from this 1 minus 1 is 0 0. Okay. 1 minus 1 is 0, and 0 minus 0 is 0. Here 1 minus 1 is 0, but after taking 1 borrow, it will become 8, and 8 minus 7 is what? 1. Yeah. So let's write difference, minterms for difference. Minterms for where? 1, 2, 3, 4. We have 4 minterms. Here 1 minterms, minterms 1, minterms 2, minterms 4, minterms 7. For borrow out, minterms are 1, 2, 3. 1, 2, 3 and 7. So let's make a key map for this. Key map solving Boolean function using key map is the most easiest way to solve any Boolean function. If you don't know about key map, you can watch my videos. I have already made videos on key map. Yeah. We have to make two key map for this, and this one is 0 1. We'll place 0 and 1 and 0 0 0 1 1 1 1 0 0 1 0 0 0 1 1 1 1 0. No. So this is difference, and this for is borrow out. So for difference 1, where 1 2 na and 4 and 7. What? No, not here. This is 6. So this one. So what I told you is if we get like this 1 1 1 1, you can directly write A XOR with B XOR with C. You can directly write A XOR with B XOR with C if we get like this in K-map. For borrow, where 1 2 3 and 7. So first will be this one, second this one, and the third group, then the third group is here this is a complement, so just write a complement for row, and for column we have two column, B complement B and just C. Here B is not fixed. Yeah, here we have a B complement because here 0 1 1. So this 1 is fixed, mean C is fixed but not B. So just write C plus okay, done. And for this 0 1 not fixed, so just avoid it. And for this for don't have to compare, so write whatever it has, BC you can write for this B and C. So for this 1 and 1 we have just one row, so write A complement, and for this B is fixed because 1 1, this first is fixed but not second because we have here 1 and 0. C is not fixed, so just write A complement and B. Yeah, this is the final solution for this. And just let's make a diagram for this. So this XOR A and B XOR with B, so this will produce A XOR with B. Just take one line for this, named it C, and just connect it with another XOR. We'll get A XOR with B XOR with C. See, for this we have to make 3 AND gate, first, second and third. 3 AND gate and one OR gate. For and one AND gate, the output this will go to this, the output of this go to this, and the output of this. Yeah, so named it A. So the here A complement, for A complement just need to make AND gate. So this will produce A complement B and just make a B line. Just this is no, this is C line, this is C, and this is a B, and for C you can take it from like this and just connect it, and here we have A complement and A complement, so you can take it from this for A complement and what B, you can take it B from this, just connect it. So finally it will produce A complement C plus BC plus A complement B. This is the final logic diagram for full subtractor. Thank you for watching video. If you like it, do subscribe, like the video, and leave your comment. Thank you guys.